Okay, next items will be solving trigonometric functions, the integrals of the trigonometric functions. Let's start with number 1. The integral of sine squared y cosine y dy. Now, pertaining to this topic, again, we will be selecting what will be the u and the du from our integrand or from our problem. So we have to set what will be the u. So selecting the one that has an exponent so that we could use power rule. We have sine squared y instead of cosine y. So u as sine y, what will be the du? The derivative of sine, that is cosine y, the derivative of y, which is the dy. Okay, now if we look at example number 1, so we could replace this one for the u and we could replace this one for the du. So we now have the integral of u squared, and this one is the du. Integral of u squared du, that is power rule again. So we will be having u cubed over 3 plus c. Or we could write 1/3 for the u cubed over 3. We have 1/3. U, we have sine y. And since this is cube, so this is cube plus c. Now for number 2, look closely. We have the integral of second raised to the power of 5x tangent x dx. Now, if we choose second x as our u, since we have an exponent of 5, so if we choose second x, the derivative of second x, that is second x tangent x dx. So we already have dx, we already have tangent. For the second, we have 5 second here, so we will be needing 1 second for the du. So the remaining value of the second, it will be second raised to the power of 4x, since we have 5 second here. And we have the 1 separated by the 5, so we have second x and our tangent x dx. This will be set for the du and this will be set for the u, and our n will be 4. So we now have the integral of second x as u raised to the power of 4, and this will be the du. Okay, so u raised to the power of 4 du, that is u raised to the power of 5 whole over with 5 plus c. Or we shall have 1/5. The u is second x, and since this is raised to the power of 5, this is u, or so this is second raised to the power of 5x plus c. That will be our final answer. Now let's proceed. We have example number 3. The integral of the quantity 2 cos 4 theta minus 1, quantity raised to the power of 1/2, and we have sine 4 theta d theta. Now we'll be choosing this one as our u. So the u will be 2 cosine 4 theta minus 1. The derivative of our u, copy 2. The derivative of cosine, that is negative sine 4 theta, times the derivative of 4 theta, which is 4 d theta. And the derivative of 1 is 0. So the du will be equivalent to 2 times 4 times negative 1. So we have negative 8 sine 4 theta d theta. So we will be correcting this one by multiplying negative 8 over negative 8. Integral of 2 cosine 4 theta minus 1 raised to the power of 1/2. And we have sine 4 theta d theta. Now, placing this negative 8 inside, we replace it with 1. So we now have negative 1, 8. Integral of, this is the u, obviously, raised to the power of 1/2. And this one, it's the du. So, integral of u raised to the power of 1/2, 1/2 plus 1, that is 3/2. So, negative 1 over 8. So, u raised to the power of 3/2 over 3/2 plus c. Taking the reciprocal of 3/2, so this will become 2/3. So, negative 1, 8 times 2/3. The u is quantity 2 cosine 4 theta minus 1 raised to the power of 3/2, of course, plus c. Notice we could cancel this one too, and 8 will be 4. Negative 1/4 times 1/3, we have negative 1 over 12. We have quantity 2 cosine 4 theta minus 1 raised to the power of 3/2 plus c. This will be our final answer. Next, we have number 4, the integral of cosine 2 theta d theta over the quantity 1 plus sine 2 theta raised to the power of 4. Okay, so if we choose the denominator as the u, 1 plus sine 2 theta, or sine 2t rather, the du should be, the derivative of 1 is 0, the derivative of sine, that is cosine 2t, the derivative of 2t, that is 2 dt. So the du is 2 cosine 2t dt. Looking back at the original problem, so we could replace this one if and only if we have 2 for the numerator. So let's multiply with 2 over 2 cosine 2t dt over, we have quantity 1 plus sine 2t raised to the power of 4. If we write this 2 inside, replace it with 1. We now have 1/2 integral of, this one is obviously the du. And how about this one? That is the u raised to the power of 4. Taking the inverse of u raised to the power of 4, so we now have u raised to the power of negative 4 du. 1/2 integral of u raised to the power of negative 4, that is u raised to the power of negative 3 over negative 3 plus c. We have the integral of the quantity 4 minus 3 sine 2 theta, quantity raised to the power of 4 cosine 2 theta d theta. Okay, now obviously we could choose this one as the u, 4 minus 3 sine 2 theta. The derivative of that, the derivative of 4 is 0 minus 3. The derivative of sine 2 theta, that is cosine 2 theta. The derivative of 2 theta, that is 2 d theta. Now the du is equivalent to negative 3 times 2. We have negative 6 cosine 2 theta d theta. Okay, so now let's check if the u and du is present in our original problem. So we choose this one as the u. Look at here, we have cosine 2 theta d theta, cosine 2 theta d theta. We need to have negative 6. Multiplying with negative 6 over negative 6, integral of 4 minus 3 sine 2 theta raised to the power of 4 cosine 2 theta d theta. Writing negative 6 inside. Replacing it with 1. So we now have a du, and we have the u raised to the power of 4. This will be equivalent to negative 1 over 6 integral of u raised to the power of 4, and this is the du. Now let's evaluate the integral. Negative 1 over 6 u raised to the power of 5 whole over with 5 plus c. Negative 1 over 6 times 1 over 5, so we have negative 1 over 30 u raised to the power of 5 plus c. What is the value of the u? Okay, we have right here negative 1 over 30 multiplied with 4 minus 3 sine 2 theta, and we have raised to the power of 5 plus c as our final answer. Number 6. Now, if you look at problem number 6, both of the two trigonometric functions has exponent tangent squared 3x minus 1, and we have secant squared 3x minus 1. But if you recall the derivative of tangent, it will become secant squared. So obviously we will be choosing tangent for the u. So the u will be tangent 3x minus 1. The derivative of tangent, that is secant squared 3x minus 1. The derivative of 3x minus 1, that is 3dx. So looking back at our original function, we only need 3 right here. So multiplying with 3 over 3, integral of the tangent squared 3x minus 1, the secant squared with 3x minus 1 dx. Rewriting the 3, okay, inside. So we now have 3 right here. So this is now the form, obviously, with u raised to squared. And we have the du. U squared du, that is equivalent to u cubed over 3. Okay? Plus c. So 1/3 times 1/3, that is 1 over 9 u cubed plus c. 1 over 9, the u cubed, the u is tangent cubed 3x minus 1. Okay, plus c. This will be our final answer.